So sometimes in some problems that are graphical in nature, you might, as a part of a problem-solving strategy, have to determine the length of a particular line segment. And so I want us to start today by looking at just sort of a generic example. So let's say, for example, I had a line segment AB formed by plotting two coordinates, one coordinate at A and another coordinate at B. So I could label those coordinates if I wanted to, as here we have, it looks like 1 and 1. And over here I have 4 and 5, right? And so I can think of really I can think of the length of this line in order to get from point A to point B. That would, that the distance between those is really just the length of the line. And so I'm trying to determine that. I know that really to get from A to B, I had to go so far in the X direction and I had to go so far in the Y direction. Right? And so in so doing, I build sort of like this triangle. And so what kind of triangle is this? Well, it ends up that we've created a right angle triangle. And so if I know what my change in X is, that forms one side of that right angle triangle. And if I know the change in Y, that forms the other side of this triangle. So I would like you to take a wild guess as to what strategy we might be able to use to solve for the length of that line. Well, I'm hoping you're thinking Pythagorean theorem, right? So that I can say that if side AB squared is going to be equal to the other sides squared and then added together, right? And I can go from there in order to solve for the length of AB. This is great for this question. Let's develop a nice formula that we can use for given any situation with coordinates. So I can extend this to a generic situation where I have two coordinates. I'm going to say that the first coordinate is, I'm going to say like x1, y1. That's its position. And then this coordinate up here would be x2, y2, right? And all I really did here was I formed a triangle that describes the change in x. And then another side of the triangle that describes my change in y, right? So if I think about this as a, Pythagorean theorem, I can think of this is my delta x, and this right here is my delta y. And then what I have here, I'm going to say, well, I can call it AB, or I can call it the length of the line, L. Well, I know that L squared is going to be equal to delta x squared, my change in x, plus my change in y squared, right? Just using Pythagorean theorem. So now remember that we get our change in x and our change in y by subtracting x1 from x2 and y1 from y2 respectively, and that will lead us to, I'm going to keep going here, L squared being equal to x2 minus x1 all squared plus y2 minus y1 all squared. Now, so moving this over to a simpler version where we have the length of the line identified on its own, I know that to isolate L, I would have to take the square root. Whatever I do to one side, I do to the other. And what that does is it leaves me with a nice formula here for the length of any line. Here I've called it AB, but I could just as easily have replaced that with L for length of a line, or D for distance between 2 points. So there it is. Quite simply, all we're doing is using information from coordinates and Pythagorean theorem to determine the length of a line segment. Let's try an example. So a typical entry-level question will say, well, find the length of the line segment joining two particular coordinates. And here we're given those two coordinates as coordinate S and coordinate T, and the values are given. So for finding the length, we can say, well, the length is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared, and then simply substitute in the values, right? So take a minute to go ahead and do that, pause the video, and then come back and check your answer. Okay, so I'm going to go ahead and sub those values in. So x2 is, I'm going to call this x2, y2, and I'm going to call this x1, y1, although I could have reversed those and my answer should be the same because I'm squaring each of the values in the brackets. So let's go ahead and do that. So x2, so -3 minus 2 all squared, and then y2 is 5 minus -4, just be careful about those negatives, squared. I'm guessing if you went wrong, that may have been where you did. So that will give me -5 squared, all squared, and 9 squared. So when I combine those values, I'm getting that I get this length of the line as √106. So this brings me to an interesting point because, it depends, each question is going to be different. If you're looking at a word problem where the length of a line segment or the distance actually has real meaning in units, you'll want to go ahead and evaluate this by taking the square root, right? So I would get some sort of decimal value, which I would round as given in the question. So for instance, in this case, I'm going to, arbitrarily round to the first decimal place. But you should know that, these represent two different types of responses, and questions might identify for you which type of response they want. So if they say, for instance, that they want an exact answer, then what they're looking for is this guy under the root sign. So they want you to leave it as an exact answer by representing it as what we call a radical. A radical is the name we give for the root sign. So, however, if they want an approximate answer or a rounded version, then they're going to want you to actually evaluate under the root by taking the square root of it and getting a value. So it just depends on the type of question, and questions may specify which they prefer. I have these definitions down in case you want to write them out in the next little segment. So there we have it. So if a question says exact answer, then they want you to leave it as a square root. They don't want you to evaluate it. And again, that depends if the value under the square root actually, can give you a whole number or not. And, for instance, I would say to you, I should say, like, if your answer for the length of the line ended up being √25, don't leave it as √25. Leave it as L equals 5, because that works out nicely, right? But I would say to you, if the question says √20 is what you get, and it says exact answer, you want to leave it as √20, and as opposed to evaluating it and getting a decimal answer. Right? So, but if a question says, on the other hand, exact or approximate answer, that's where you're going to evaluate the radical. You're going to write the value as a decimal. So here's a fairly typical question that you'll get that is sort of not your baseline question, but asking a little bit more out of you to apply your understanding of other concepts along with the length of a line segment. Let's take a look at it. It says, triangle ABC has vertices. Vertices means corners. A, B, and C, so those are the three corners of the triangle. And it says classify the triangle by side length is the first part of the question, and calculate the perimeter of the triangle. So let's tackle that first little bit. And we know that the triangle is going to be, one of three different answers based on, if we're classifying based on side length, right? So here are the possibilities. Let me write that out for you. So we know that if we have a triangle with all three sides that are the same, well, what do we call that? We call that a scalene, no we don't, we call that an equilateral triangle. We know if we have a triangle that has two sides the same, we call that an isosceles triangle. And we know that if we have a triangle where none of the sides are the same, then we know we have a scalene triangle. So we know we have one of those three possibilities. How are we going to classify our triangle? Well, we're going to have to find the length of each of the sides. So I typically find it easiest to draw sort of almost like a diagram to help me visualize. So take a minute to do that for yourself, and then we'll come back and we'll keep going. So I've quasi sort of plotted these points, in my imaginary Cartesian plane. And the accuracy doesn't matter here because really I'm just doing it to help me visualize. So now I have to go about the business of determining each of the three different side lengths and then compare them. So I'm going to determine the length of AB, the length of BC, and the length of AC as well. So take a minute to go ahead and calculate those three side lengths and see how you do, and then that will help us to answer the question, which is to classify it. All right, so I've gone ahead and I've evaluated the length of all three of the sides, and you can see them color-coded here. So AC is 10. It has a value of 10. I'm just going to write this in my diagram, 10. The value of BC is 16, and the value of AB is 10. So given all of that, what type of triangle is this? Well, it's a triangle with two sides that are equal and the other side that is different. That means that this is therefore an isosceles. I'm not sure if I'm spelling this right. I think I am. Triangle. All right, so part B, you'll remember, of this question was, what is the perimeter, right? Well, the perimeter of a triangle is just as it is with anything. The perimeter is just, the distance around, right? So if I know that each of the side lengths, I have two side lengths each with 10 units, and I have the third side length that is 16 units long, then that gives me a total perimeter of 36 units, whatever those units might be. So I hope you found that question to be manageable. And I'm going to give you some practice questions to try if you feel you want to practice this skill. Maybe at least at a minimum, maybe just take a read through the question types to see if there are any that you think you would struggle to answer. Maybe those are the ones you should spend your time on. And as always, reach out with any questions that you might have.